Hello everyone. Today we will learn how to prove that the square root of a prime number is an irrational number. For this, we will take the example of root 3. The first step is to assume that root 3 is a rational number. If root 3 is a rational number, then root 3 can be expressed in p by q form where p and q are co-prime integers. Now if root 3 is a rational number, then root 3 is equal to p by q, where p and q are co-prime integers. Co-prime integers are the integers which do not have a common factor except for 1. Now, this will imply that root 3q is equal to p. It's a simple cross multiplication. Now, squaring both the sides of this equation, I get 3q square is equal to p square. I'll mark this equation as 1. Now, if 3q square is equal to p square and q square and p square are co-prime integers, then this means that 3 will divide p square. If 3 divides p square, this implies that 3 divides p. Now this step is important. Why does this happen? I'll explain it to you with the help of an example. If 3 divides 36, or I can say 3 is dividing 6 square, which is true, I can also say that 3 divides 6. It's true. So, in the same way, also again, one more example. If 3 divides 144, 144 is basically 12 square. So, if 3 divides 12 square, I can also say that 3 divides 3 divides 12, which is also true. So, if 3 divides p square, then 3 divides p. Now, if 3 divides p, I can say that there exists an integer r such that 3r is equal to p. It's just the logic of multiplication. If any number is dividing the other number, then there is a third number which when multiplied will give you the result. For example, if 3 is dividing 12, then there exists an integer 4 which multiplied by 4 will give us, which when multiplied by 3 gives us 12. So, I can say there exists an integer r such that 3r is equal to p. I mark this equation as 2. Now, I substitute equation 2 in equation 1. So, I write it as 3q square instead of p square, I write 3r whole square, which gives me 3q square is equal to 9r square. Then I get q square is equals to 3r square. Cancelling 3 from the left hand side and the right hand sides. Again, this is same as the previous step. If q square is equal to 3r square and q and r are co-prime integers, so I can say 3 divides q square, and in this previous way I can say 3 divides q. Now 3 divides p also, and 3 divides q also. 3 divides p, you can see from here, and 3 divides q also. This means that 3 is a common factor of p and q. But we had assumed that p and q are co-prime numbers, and co-prime numbers are do not have a common factor other than 1. So, if p and q are both being divided by 3, this implies to me that p and q are not co-prime, which is a contradiction. Hence, our assumption is wrong. This means we have assumed something wrong. So, we had assumed root 3 to be rational. Hence, since our assumption is wrong, I can say root 3 is an irrational number. And we have proved that root 3 is an irrational number. Now, I can similarly prove root 2, root 5, root 7 or the square root of any prime number to be irrational in the same manner. This is a very important question from your C.B.S.E. board point of view. Now, the question which comes in the exam is either a direct question like prove that root 2, root 3, root 5, root 7 to be irrational number. So, you will prove it in this way. It's going to be a 3 or 4 marker question. The other type which comes in the exam is to prove that 5 plus root 3, 5 root 3, 5 minus root 3, 2 plus root 3, 2 plus root 2, 2 minus root 2, 2 plus root 5, applying all the operators with root 3, root 5 and root 7, the number formed, we have to prove it as to be irrational. Now the proof of this depends upon the weightage of the question. If it is a 1 marker or 2 marker, then we can just write directly that since, for example, I want to prove 5 plus root 3 is irrational, I'll just write that root 3 is irrational. So sum of a rational and irrational will be an irrational number. It's as simple as that. Similarly, if I had to prove 5 root 3 to be irrational, I'll just write root 3 is an irrational number. So the product of a rational and an irrational number would be an irrational number. But this is for a 2 marker or 1 marker question. But if it is a 3 or 4 marker question and you have to prove the same question 5 plus root 3 or 5 root 3 to be irrational, then in that case you will prove root 3 to be irrational first, the way we had done earlier in the starting of the video, and then you will say that root 3 is irrational and 5 is rational, so the sum of a rational and an irrational is an irrational number. Similarly, for 5 root 3, you will prove first that root 3 is irrational, and then you will write down that the product of a rational number and an irrational number is an irrational number. So this is how we prove a number to be irrational. This is a very, very important question from C.B.S.E. point of view. Thank you.